This video is going to go through some double replacement practice problems. I'm going to go through these fairly slowly, so it's up to you how much of them you want to watch. There are going to be 10 problems in total that I go through. Feel free to pause and try them on your own and then check if you would like. So the first one that we're going to go through is number 1 right here. I'm going to be using some color coordinating here. The best way I prefer to start is to identify what charges everything is and what my cation and anion pairs are, so that way I can correctly make formulas on the other side for my products. So to start, I have iron. In this situation, iron is +2. That is my kind of cation for that one. And then I have sulfate. Sulfate is always -2. That's how I know that iron is +2, because I don't see a 2 subscript on iron from the sulfate, so it has to be the same charge. Looking at lead, this is going to be lead 2 as well, since I see that 2 right there. And then I have nitrate, the -1. Now this 2 came from lead, and so when I pair up the new things, that 2 does not need to come over. So I'm going to use my inside-outside method here, putting these ones together. So I have iron with its +2 charge, and then nitrate with its -1. Now, when I make this formula, I'm going to swap and drop or crisscross, however you want to think about it. But that 2 goes to nitrate, and then the 1 comes over to iron. Now, you will notice that I did end up with a 2 outside of the parentheses, just like I had on the left. But the reason for that is because iron was also a 2 charge, not because it needed to still have that subscript of 2. And then I'll go ahead and I'll put lead, which is +2, with sulfate, which is -2. And those will cancel, and so I will get PbSO4. Now, after I make my correct pairings, the next thing to do is check my solubility. So if you look here, I have iron and nitrate as my first combo. That is going to be soluble. Next combo was lead with sulfate, and that is insoluble. And so the one that is considered insoluble is going to be my solid. A little confusing because we're going to put S, but S will not mean soluble. S will mean solid here. So I'll go back up to the top and I'll label this as my precipitate, which is a solid, and this as aqueous. Now looking at my 4 things in order to balance here, it is already balanced, but I'll just kind of prove that to you. So we have iron, we have 1 of each. We have sulfate, we have 1 of each. We have lead, 1 of each. And then we have nitrate, 2 on each. And so this would be the completed answer. So it's up to you if you want to be putting kind of all of that mess. This is really all I need to see. Again, if we don't need coefficients, it's assumed if you don't have a number in front that you need 1. So that would be the finalized answer. Okay, so here's the second problem. If you want to pause and give it an attempt, I'm going to go through it now. So pause, I'll give you 2 seconds. Okay, just like before, I'm going to start by figuring out what all my charges of everything is and what my cation and anions are. Now I'm going to put my inside and outside together. So I have zinc. Didn't make that arrow quite far enough. It's supposed to go to phosphate. Zinc going with phosphate. And so making the correct formula here, the 3 will come over, and then I'll have parenthesis with a 2. And then I have potassium going to combine with chlorate. So looking here, I'm going to have obviously 2 compounds that I've correctly made. Now I'm going to erase a little bit of this just to show you what we want to avoid. So notice this 3 on potassium is not over here. And that is because the 3 came from phosphate, but now it's no longer with phosphate. It's something that with something that has a 1 charge. And so when we make the correct ionic formula, we need to consider that. The 3 now is going to be on zinc because zinc is the thing with phosphate. And this is important. Obviously, our number of everything is changed, but that is okay because that is what we will balance. So going back down here, erase some of this from before, we had zinc, which is here, and that was going to be with phosphate. So that is going to be insoluble, meaning we do end up making a precipitate here. And then we have potassium, which was alkali metal with chlorate. Both of those are things that are always soluble, so that will definitely be aqueous. So going back up to the top here, we're going to say that this is our solid and this is aqueous. In terms of balancing, it's up to you if you want to show work for it, or if you want to just kind of eyeball it. All I care about is seeing the correct coefficients. I don't necessarily need to see the work, but I'm going to show you how I would do the work if I were to write it out. If the polyatomic ions don't change, which they shouldn't be, it will be much easier for you to balance them as one thing. So I have chlorate and chlorate, phosphate and phosphate. Notice both of those have oxygen in it. So if I try to separate by element, I'm going to have 6 things or 5 things to balance, and oxygen is going to appear in every single compound. It's going to be much harder for me than if I just count them as one thing. So I have 1 zinc over here, I have 3. And then I have 2 chlorates and 1. I have 3 potassium and 1, and then I have 1 phosphate and 2. The trick here that I always tell students is start with the one that looks the most complicated or ugliest first. It has the most like swapped over subscripts, which is this compound right here. If I start balancing the stuff in that, then it's going to be much easier for me to not have to go back and change subscripts. So I'll start by putting a 3 in front. That 3 will change my zinc. It will also change my chlorate to a 6. Then I'm going to do phosphate. Phosphate needs to become 2 here. That becomes 2. And then this also becomes 6, which means I end up with a 6 in front here and then assumed to be a 1. If you had not started with zinc or phosphate for balancing, you probably would have had to go back and change this coefficient here because it would have become undone. Okay, that would be your final answer then, what I have kind of on the product side. Okay, number 3, go ahead, pause again if you want to try this one on your own, but I'm going to begin in 2 seconds. All right, we have Ag plus 1, sodium plus 1, minus 1, and minus 2. Putting our inside and outside together, I have silver. That's going to end up with carbonate. And I have sodium. That's going to end up with acetate. It does not matter what order these 2 things come in on either side of the plus, as long as the correct cation and anion are paired together. So this is a 2 and a 1 charge, meaning that 2 has to cross over here. So this becomes Ag2CO3. And then these are both 1, so that would just be the formula. In your final answer, you do not need to write the charges. But if they are there as you're kind of figuring it out, that is fine. Next, we're going to check solubility. So again, erase what we had before. We have silver with carbonate. That is our solid precipitate. And then we are going to have an alkali metal with acetate. Both of those are always soluble. So again, we have 1 solid and 1 aqueous. So I will label that S and AQ. Now, again, it's up to you if you want to be writing out all of your work like we did for this problem above. Most of these for double replacement are going to be fairly straightforward, and you can generally balance them just by kind of keeping tally in your head. So for example, in number 3, I see I have 1 silver here and 2 here, which means I will need a 2. So now that will be 2 silvers, right? And 2 silvers. So that is okay. This is 2 acetate. This is currently only 1 acetate, so I'm going to put a 2 there. So now that's 2 silver, 2 silver, 2 acetate, 2 acetate. Then I look at my sodium. Sodium is 2, but because I already put a 2 there, now that's also 2, so that is balanced. And then 1 carbonate, 1 carbonate. So this would be all I would have to do to balance. If it's easier to make the list, make the list. If not, feel free to just kind of, again, count in your head and tally and see. Some of them are fairly straightforward, but that would be the final answer. Okay, I'm going to do one more, this kind of slowly, and then I'll start picking up pace a little bit. So here we're going to have lithium, and we're going to have sulfate. Here we're going to have ammonium, and we're going to have hydroxide. So we are going to go ahead and swap those inside outside. Didn't go far enough. So we have lithium, and we have that going to be paired with hydroxide. And then we have ammonium, and that's going to be paired with sulfate. Okay, go ahead, lithium hydroxide, that's the formula. And then we would need to put this in parentheses with the 2 to have that crossover. Now we're going to go look them up on our solubility. And we see lithium is alkali, so no matter what it's with, it's always soluble. And we also see that ammonium, no matter what it's with, is always soluble. So in this case, this is our first example of 2 products that are both aqueous, which means I do not need balancing in this case because no reaction will have taken place. If everything just stays aqueous, nothing has been produced. Okay, I'm going to put up the next 3 problems if you want to pause the video here and try to do those. And like I said, I'm going to kind of pick up pace a little, go through them more quickly. In number 5, we will have magnesium pair up with nitrate to make that formula that you see there, and silver pair up with sulfate. When we look up the solubility, we're going to find that magnesium nitrate is in fact aqueous, while silver sulfate is a solid. Going through and looking at our coefficients, we'll realize that on the left we have 1 magnesium, on the right we have 1. We have 1 sulfate on the left and right. We have 1 silver on the left, but 2 on the right. So this will need to become a 2 coefficient. And then we have now 2 nitrates on each side. So that would be the balancing there. For number 6, zinc will pair with nitrate to make this formula based on their charges swapping. If you look this up, this will be aqueous. Then we have silver combining with bromide, which will be a solid if you look on your solubility chart. So this reaction will happen. We'll then go ahead and check our balancing. We have 1 zinc, 1 zinc. We have 2 bromine on the left, but 1 on the right. So this will need to have a 2 in front of it. Now that we put that 2 there, there's 2 silver on the right side. So this will also need to be a 2, but then that will help balance our nitrates to be 2 and 2. And then number 7, we have ammonium combining with chromate. And so we're going to look that up for solubility. Ammonium is always aqueous no matter what it's with. So this ends up being aqueous. And then if we look up MgSO4, this is also aqueous. And so for this reaction, nothing will happen. So I do not care about balancing. I put NR and finished. Okay, 3 more. I'll have you, actually, yeah, 3 more. I'll have you pause the video and you can try these 3 and then check your answers. Okay, for number 8, nickel will combine with sulfate. correct formula should be Ni2S3, and then ammonium with chlorate. So nickel and sulfate will form a solid, while both of these things, ammonium and chlorate, are always aqueous. So looking here, we're going to need a coefficient in front. Didn't leave myself really enough room to put that coefficient, so I'm just going to slide that over. Because nickel is going to need a 2 here to balance that 2. Sulfur is going to need a 3, which will create 6 here for both ammonium and for chlorate. Looking at the next one, this is a slight typo. Iron should be 2 or 3 charge, but here it's listed as a 1 charge. I'm just going to write the reaction based on that, but ideally there would have been a 2 or 3 there. But we're just going to go with what the charges say. So here we have calcium is 2 charge. That makes a formula. Chlorate, again, no matter what it's with, is always aqueous. And then if we look at iron hydroxide, this is going to be a solid. And so looking then at what we have here, we're going to find we need some coefficients, specifically just a coefficient on this and this. Also, this should be a plus. That's another typo. Finally, for the last one, here, this is always aqueous. Again, just looking down at our chart, no matter what ammonium is with, it is always considered aqueous. And then fluoride with magnesium, you can see, is a solid. So we will need to balance this. This one is fairly straightforward to balance. It just will need a 2 right there. And that's just some double replacement practice.